So welcome to the review for Unit 10 on real-world functions. So we started by graphing real-world functions. It says Karen earns $20 per hour. So that's going to be our slope. It's also how much we're going to go up every hour. And a one-time upfront fee of $30. All right, so she gets, for 0 hours, she gets $30, and then we're going to go up by 20. So 1 hour later, she should be at 50. Now each box here is worth 10, right? She's getting 20 more dollars. Should be a straight line. 20 more dollars per hour. So then she should be at 70 at 2 hours, right? And then she should be at 90 in 3 hours. And this is going to be a straight line forever. So we really want to use a straight edge here and draw a linear function. This is a linear function because it's the same constant $20 per hour each time. So let's fill this table in. So 2 goes with 70. I didn't put 0 in here. 0 would go, right? 0 would go 30. 1 would go with 50 because it's $30 upfront fee. That's our y-intercept. And when we're adding 20 each time, 4 better go with, or 3 goes with 90. I almost made a terrible mistake. 3 goes with 90. And so 4 goes with, oh, it's off the graph, right? 110. So this, to fill in the table, what we really need is a linear function. We need pay as a function of hours. P of h equals 20h plus 30. Right? So 6 will be 20 times 6 plus 30, which is 150. Right? We're going up by 40. Going up 20 for 1 hour, 40 for 2. 20 times 8 plus 30. And so that's 160 plus 30, 190. And then 20 times 10 is 200 plus 30 is 230. All right. So please, you can always fill in the table using the equation. If you can read them off the graph really easily, yes, you can do it that way. But I intentionally made this tricky. You got to make sure you understand that they don't always go up 0, 1, 2, 3, 4. Okay. All right, so the water is going down. All right, so what's its y-intercept? Its y-intercept is 16, 0, 16. And let's check the scale. It's just 1 box is worth 1. Now let's see if we can find the good intersections. There they are. So what's the slope? Well, 1 box is worth 1, so we're going down 1 and 4 and over 1. So the slope is -4. Okay, so if we use h of t, height as a function of time, equals -4t plus 10. Okay, that is the description of this, well, plus 10. Why did I put this? Oh, I'm very sloppy, and look what happens, 16. Don't do that, right, because it starts at 0, 16. And so then if I ask you, what's the height at 3 hours? You do h of 3, -4 times 3 plus 16, which is -12 plus 16. And you would say, oh, it's at 4. I didn't say inches or feet or whatever. Okay, and that's a good use of that. Okay, write a linear function to describe the height of a plant over several days. All right, so let's look at the scale. 1, 2, 3. Oh, but this is going up by 2s. All right, so that is 20 there. So the y-intercept here is 0, 20. Now let's do the slope. So the slope, there's a good intersection. Remember, you want to do more than just 2 points so you can see the pattern, right? I have an equally distant pattern. Now it looks like 1/4, but it is not. The run is 4 days, right? Run is 4 days. Well, what is the rise? It is not 1 because each box was worth 2. You need this number. So the rise is 2. So it's 2 over 4, which is 1/2 is the slope. So we're going to do height as a function of days equals 1/2 d, d for days, plus 20. That's what made that linear function. Right? And if I then say, find how much it is at 20 days, well, it'll be 1/2 times 20, which is 10, plus this 20 over there. And 20 better go with 30. Is that the point, 20, 30? Let's see. Yeah, because they're each going, oops, I'm off by 1. Oh, sloppy. Yeah, that's 30 right there. Because that's 26 and that's 28. Very sloppy, Mr. Ben. There you go. Okay, so we're going to do the same thing here. So first thing you always have to do on these, find your slope, right? So I'll just do it right there. 17 minus 9 over 4 minus 0. So we get 8 over 4. The slope here is 2. What does that mean? Cost per ride was $2 per ride. That's what it was. Is the y-intercept there? Yeah, it is. Right? There's the y-intercept. What does it cost to get into this fare? Right? What is the entrance fee? The entrance fee is $9. It says right there. You go on 0 rides, you pay 9. That must be the entrance fee. So what's the function here? Now I didn't say what letters to use, but don't use X and Y. I want to use C for cost and R for rides. So it's 2 times the number of rides plus $9. 2R plus 9. Do not put dollar signs in here. Do not do that. Okay, I get students for, right? We don't put units in our equations. All right, so now we're going to do this one. Find the speed of the car. All right, so we're going to find the slope. So 170 minus, that's 7 minus 120 over 2 minus 1. Oh, they're going 50 miles per hour in this car. But we don't have a y-intercept. Now, this one, you could use the pattern to figure out what the y-intercept must be. But let's use our technique. Y equals 50, x plus b. We take any one of those. I'm going to do the first one. Why not? Then we subtract 50 from both sides. 120 minus 50 is 70. The y-intercept is 0, 70. So they were at 70 miles when they started, right? And then we're going 50 miles per hour. So what's the equation? M of h, miles is a function of hours. The speed is 50, so 50h, and we started at 70 miles already. M of h plus 70. Okay, now we're given 2 heights of the candle. We know at 2 hours it was at 15 inches, and at 4 hours it was at 7 inches. It was shorter, right? Candles burn down. We have to find the slope, subtract our y's. 15 minus 7 is 8. 2 minus 4, because if I start with 15, I got to start with 2. I get negative 2. It's going down 4 inches per hour, right? The rate it's burning, the rate the candle is burning is down 4 inches per hour. Okay, do we have a y-intercept? No. So we got to put the negative 4 into y equals mx plus b. I'll take, why don't we do the 7 and the 4? Now, 7 equals, right? 7, c, the y is 7 when the x is 4. So we get 7 equals negative 16 plus b. We're going to add 16 to both sides. So 23 equals b. This candle was 23 inches when it started. All right, and so the equation here is candle. I use c for height here so that I could have c of h instead of h of h. C of h equals negative 4h. Whatever that letter is, it's always the same there, always. All right, c of h equals negative 4h, and it started at 23. It was going down 4 inches per hour and started at 23 inches. All right, so this is a scatter plot, and so how I can deal with this on a test is, notice I have multiple choice. Right, so the question here, let's look at the y-intercepts. Well, this one's 5, this one's 0, this is 1, and this one's 5. So what do you think? So these are, both graphs are going up by 5. Okay. So I think that 5 might be a good intercept. Now, if I do that, I have a choice of slope of 1/4 and 4. Well, if I do 4, that's over 1, because each box is worth the same. That's this. So there's no way it has a slope of 4. It certainly has no way it has a slope of 20. So really the only reasonable ones are the 2 that have the slope of 1/4. And so let's see that. Right, hopefully I've graphed this already. There it is. Right, there it is. Because you go over, it's over 1, 2, 3, 4, 1, 2, 3, 4. That's there, thank you. That's why you do more than one intersection. Right, so it's over 20 up 5, but 5/20 simplifies to 1/4. Now the question is, it's the second most reasonable response was B, But think about this. If you start this at 0 and it's parallel to it because it has the same slope, it's too low if it starts at 0, 0. Every dot is above it. That's why it can't be B, right? If you do 1/4 and start at 0, 0, it's no good. So you can do, graph multiple ones, and by process of elimination, figure out is this one. The percent of pool usage as a function of temperature, right? This is a graph about the hotter it gets, the more people go to the pool. And our data in this case came out linearly. So we could write a linear function, a line of best fit. Okay, in this one, we're going to find the speeds in each section, and then we're going to label whether they're constant or increasing. So in this section, right, we went 1, 2, 3, 4, 5 boxes, but they're each worth 4. So we went 20 miles in the 2 hours. So that's 10 miles per hour. In B section, right, we started at 20, but we stayed at 20 the whole time. It's horizontal. So we went 1, 2, 3, 4. We went 0 miles in 4 hours, which is 0 miles per hour. And in section C, we went for just during that 1 hour, we went up 2 boxes from 20 to 28. We went 8 miles in that 1 hour. We went 8 miles per hour average speed, but this is increasing. We were going less than 8 at the beginning. All right, it's increasing or speeding up. Either way, you could say it. Right? Increasing the speed or speeding up. And in section A, we were going at constant speed. Section B, you're going 0. Okay. All right, so plot a graph in which you start at home. That means start at 0, 0. Then drive 125 miles. So we got to get to 125 miles at a constant speed in 2 hours. So we got to get there. And it's got to be a straight line, something like that. Okay. Next section, for the next 3 hours. So, right, we went 2, now we're going 3 more. We should end up at 5. Drive another 100 miles. So we did 125, and we got to go another 100. So we're going to get a 225. So we got to end up there. And it says slow down as you drive that. All right, so it's got to look something like that. We got to bend it that way to show it's slowing down. Oh, normally I do blue next, but too bad. Stay where you are for an hour. Okay, so that means now at 6 hours, and we didn't go any more miles, right? We're at 225 and we stayed there. And turn around and return home at a constant speed of 75 miles per hour, right? So 75 miles per hour is 3 boxes. So let's do that. So we have to go 1, 2, 3 every hour. 1, 2, 3 every hour. 1, 2, and we get home in 9 hours. And it says constant speed, so we got to do a straight line. And that's pretty yucky. Let's try to do better. Yeah. All right, it looks like that. Make sure it's not bent. Right here we have 2 data points. We know that at 5 hours he got paid $225. At 7 hours he got paid $285. Right, so we find our slope, 285 minus 225. This is what would be on the y-axis if you graphed it, right? And then this would be 7 minus 5. So 285 minus 225 is 60. And 7 minus 5 is 2. So he's getting paid 30. What's 30? $30 per hour. His rate of pay, right, is $30 per hour. The slope and the rate of pay will be the same. But we don't have the y-intercept for our graph here. So we need to put the 30 into y equals mx plus b. And we use either point. Let's use the 225 and the 5. 30 times 5 is 15. So this is 150. So we're going to subtract 150 from both sides. I get 75 equals B. What does that mean? He got paid 75 bucks for just showing up. That's his one-time upfront cost. And so if we're going to use P as I asked and H, it's P of H equals 30H. Right? These letters are always the same. 30H plus the $75 for showing up. So this is the value of a car, right? We've talked about this. Do not write a linear function. If it says, is it appropriate? No. Why not, though? You're going to have to know the reason. The reason is this is nonlinear data. It can be nonlinear because it's curved. It can be nonlinear because it's random, right? We talked about sleeping and going to the pool the next day. Right? They're not a function of one each other. They're not related, so they're non-linear. Only write linear functions for linear data. Good luck on the homework and good luck on the test.